Okay, so today we're going to talk about section 9.2, factoring using the distributive property. So we did GCF, so now we're going to look at some other things. We've used the distributive property before to multiply, so you all remember. Let me get some color here. Okay, so to distribute, we would multiply by distributing. We would get 6x cubed plus 15x. So that's multiplying. Factoring is the inverse of multiplying. So let's think about that for a minute. If I have you multiply 6 times 2 to get 12, that's multiplication. If I ask you to factor 12, you write that the factors of 12 are 6 times 2. So factoring is really undoing multiplication. So when we talk about polynomials, this is our multiplication process. Our factoring is going to be using the distributive property to pull out the greatest common factor. So let's look and see how that works. So now we're going to reverse the process to factor a polynomial. So let's look at this one first, 6x cubed plus 3x squared. We're looking for a monomial times a binomial. In other words, the factors, the multipliers that created this to begin with. So greatest common factor again. 6x cubed factors to 2 times 3 times x times x times x. 3x squared factors to 3 times x times x. So the greatest common factor is 3x squared. So I'm going to put that out front. That's my multiplier. And the question is, what did I multiply 3x squared by to get my 6x cubed? Well, I multiplied it by 2x. So 2x. And what did I multiply the 3x squared by to get 3x squared? Well, the only thing left is times 1. So plus 1. So that's pulling out the greatest common factor to create two factors, a monomial times a binomial, that are the factors of the original binomial. I'm going to do a tough one for you, and then we'll do some more easy ones when we get going in class. So I need the greatest common factor of all three of these pieces. Looking at the numbers, we can see that the greatest common factor is 4. Looking at the x's, the largest number of x's that all of them have is the single x here. The y's, the largest one that all of them have is the y squared. So that's my monomial, my greatest common factor that I've pulled out. Now we've got to think about, what do I multiply this 4xy squared by to get each term? Well, 4 times 3 gives me 12. X times 1, so that's the x is good. The y squared, we need another y to get my y cubed. The middle term, I already have my 4. I've got one of the x's, so I need an x cubed, and the y squared matches up perfectly. Then to get the last term, 4 times 2 is 8. X times x squared is x cubed, and y squared times y cubed is y to the 5th. Okay? I know this is a little different. We're going to do plenty of them in class. So the other thing that we have to know is that you've got to factor completely. So when I first look at this, the number that comes to mind that goes into both 128 and 16 is 4. And then of course I'm looking for my greatest number of x's that both of the pieces have, and that's my x to the 4th. So 4 times what gives me 128? That would be 32, and I need one more x for that piece. And 4x to the 4th goes into 16 4 times. Now when I look at this binomial, I can see that there is another common factor that I missed. And to factor completely, each binomial has to have all of the common factors pulled out. So 4x to the 4th, then I'm going to pull out another 4. That leaves me with 8x plus 1. 4 times 4 is 16. I can multiply these back together so that my monomial now is in fact my greatest common factor. Okay? All right, let's look at a couple other little things here. Sometimes we need to factor by grouping. If you look at these four terms, they don't have anything that's in common to all of them. Let's do our factoring off to the side again. I've got 2 times 2 times A times B. I've got 2 times 2 times 2 times B. I've got 3 times A, and I've got 2 times 3. Now, a bunch of them have a 2 in common, but there's no 2 in this 3A term. A bunch of them have an A, but not all of them. So there's really no common factor that I could pull out to the front. But if I put this group together and this group together. Now, the common factor for 4AB and 8B is 4 and B. That's what they have in common. So 4B is my common factor, leaving behind an A and a 2. My common factor for the last two terms is the 3 and the 3. So keep bringing down my plus sign, and the leftover is the A plus 2. Now notice that these two groupings are identical. I can now undistribute again, and I'll show you how this works. I'm going to take the 4B and the 3 and join them together, and then the A plus 2 is a common factor that I write just once. Now it looks like I should have two of them, but let's think about this backwards. This is my final factoring answer. But if I look at this over to the side and see how we got there, okay, if I was going to multiply this, I would do 4B times both the A and the 2. That's what this says. And then I would do the 3 times the A and the 2. And that's what this piece says. So in fact, when I undistribute, I end up with one of the A plus 2 terms. We'll look at this again in class as well. I'm going to do several of these in class because I know that this is a little bit confusing. All right, so factor by grouping when you have 4 or more terms, terms with common factors that can be grouped together. In other words, on the last one I grouped the first two together and the last two together, and the two common factors are identical or are additive inverses. We'll talk about that in a second. So the situation was that I had 4 or more terms. I could group them to find common factors, and once I did, these two pieces were identical. So that allows me to use factoring. All right, let's look at a grouping where it turns out with an inverse. Again, I'm going to group together here. And I know this is sometimes hard to see these common factors. That's why we're going to work on this a whole bunch. So I'm going to pull out a 5x, which would leave me with a 7 minus y. For these two, I'm going to pull out a plus 3. Remember, with the grouping, I'm bringing down that middle plus sign, and I get a y minus 7. Now, 7 minus y and y minus 7 are not identical. But let's see what we can do to fix that, because they're kind of opposites of each other. The 7 was positive here and negative here. The y was negative here and positive here. So if I pull out a negative 1, that will leave me with negative y plus 7. I've changed the signs. Now, if I rewrite, 3 times negative 1 is minus 3, and if I switch the order of these two, now I have my identical factors. Again, the outside monomials are grouped into one binomial, and the common factor is written by itself. So there's the grouping. Again, get this down, look through these a couple of times, see what I'm doing, try and work on the process in your head, and we'll work together in class. Okay, now we're going to move to equations. So far we've been just using expressions, things like 3x squared minus 2x, and we've just created our factors. Now the question is, what happens when I take that same expression and make it into an equation? And then how do we use factoring to find out what x could be? So let's look at the zero product property before we get to that. And this is an important property, and it's kind of a common sense thing. If the product of two factors is 0, then at least one of the factors must be 0. In other words, if a times b is 0, then either a equals 0, b equals 0, or both a and b are 0. Can you think of any two numbers that you could multiply together to get 0 where one of those doesn't have to be 0? I can't think of any two numbers that I can multiply together to get 0 unless one of these is 0. So when we have a product of any two things equal to 0, like, well, we got to factor it first, hold on. Then we can always set them equal to 0. Alright, so let's look at the first example. Solving an equation by factoring and setting the factors equal to 0. So the first thing I'm going to do is factor this. Pull out the 3. That leaves me with an x minus 2. Now I have two things, the 3 and the x minus 2, that are being multiplied to get 0. So either 3 has to equal 0, that's my first factor, or x minus 2 has to equal 0. Well, this is impossible. 3 cannot equal 0. So therefore I know that this factor has to equal 0 in order for the product to equal 0. Well, in order for x minus 2 to equal 0, x has to equal 2. Therefore our solution is x equals 2. Now this equation you could have solved the way we've done it in the past. Add 6 to both sides and divide by 3. So two methods of solving this: one, isolating the x like we've done before, or using factoring. Now the reason we want to learn how to use factoring is that if you look at this equation, this one we can't solve by moving the d to the other side because I still have two d's, and that doesn't give me a solution. So we're going to do our factoring. The only factor is d. 3d minus 11 is my binomial factor. So in order for these two pieces to multiply together to 0, I'm going to get d equals 0 or 3d minus 11 equals 0. D equals 0 is a very good possible answer. This one I'm going to move the 11 to the other side, and d equals 11/3 is my second solution. So there are two solutions to this problem, and you're going to find that second degree equations often have two solutions. So that's how we solve a second degree. We factor first, we set both factors equal to 0, and solve both mini equations. Okay, sometimes the factors are already done for you. So I already have two things being multiplied to 0. So all I have to do is break them apart and say the first one could equal 0, or the second one could equal 0. And now we're going to solve this just like we always have. Add 5 to both sides, so d could equal 5. And for this one, d could equal -4/3. Let's look at this last one. You notice here that the equation is not in factored form. So the first thing I have to do is always set the equation equal to 0. So I'm going to subtract the 7x. Now I can factor, pull out the x, and now again my two factors, either x has to equal 0 or x minus 7 has to equal 0, which means x equals 7, x equals 0 are my two solutions. And that's it. I know it's a lot, but we will look at it in class, I promise.